by my friend and colleague and wingman today, Noah Flaherty, who will do his best to answer questions. And of course, if there's something that a lot of you are asking simultaneously, it's probably because I explained something badly or left out an important step, and he might interrupt just so that we can make sure that we cover that. That said, this is scheduled to go an hour. It probably won't go an hour. We have some material to go through, and my job is to try and educate you on the best practices within Onshape. The title of this presentation is Multi-Part versus In-Context versus Derived. Why are we even having this webinar? We're having this webinar because over time, Onshape, on a very aggressive schedule, releases new functionality, capabilities, and supports new workflows. And perhaps without you being specifically made aware, there becomes available workflows that are perhaps more efficient than others. The purpose of this webinar, thank you for signing up, is to show you some of those new workflows so that you can make a decision as to the best one for yourselves. Okay. Jumping straight in, I'm going to make a number of assumptions. I'm going to assume that you have some Onshape experience. I realize that there are varying experience levels here in this webinar. You will have the ability to remember, ask questions, as well as view the recording afterwards, but I'm going to move forwards assuming that you have some familiarity with Onshape. I'm also going to assume that you have some familiarity with other professional grade CAD systems, be it SolidWorks, Inventor, Solid Edge, CATIA, NX, and so on. And I might make reference to some of those other systems. Sorry, I left Creo off. No slight to you Creo users, so that you can see where analogs perhaps exist between the workflows in Onshape and your previous systems. We will be going through some slides, some discussions about best strategies, and some worked examples so that you can see how the theory would be applied in practice, and you are, of course, able to ask questions as we go along. At the end, we'll have a little bit of a summary, and we'll just recap some of the ways that you, as a user, can get help from Onshape. So, as an opening statement, I'm just going to say, parts have friends. And for those of you that have built anything more than one part, you've probably already noticed that parts can be related one to another by association. The classic example is the top and the bottom of something, the left and the right of something, two parts that screw together, a motor that screws into a gearbox. There are geometric relationships that exist between the parts just by the nature of their function. You'll also notice that parts can have geometry that's related to the spatial relationships between that part and others around it. Think of an assembly where a hole becomes drilled through two parts, and the location of that hole is dependent upon the spatial relationship of those two parts in the assembly. Geometry might also be dependent upon the stage of a workflow. Think of a weldment. You have individual cut lengths that are then welded together or joined together that then might be gusseted or reinforced in some way. So the actual geometry, the thing that has the parts number, may change depending upon the stage of the workflow. And another example of parts that are related to one another might be parts that are joined together as part of the development process. Think of the handle of a handheld tool that's joined to the effector at the end. The handle might be a standard part, the effector is the one that you're designing, and you're going to marry the two together. So there are a number of different ways that we might want to relate parts one to another. Within Onshape, there are a number of workflows that enable us to do this. By name, I'm going to call them out as multi-part part studios, by the ability to create in-context relationships one to another, and the ability to derive, the ability to start with an initial state and then modify it. And we're going to go through and look at the pros and cons of using each of these workflows for each of these cases. The multi-part part studio introduced by Onshape is a very powerful concept. Initially, people tend to look at it in the same way that they did perhaps a file in a traditional file-based CAD system that enabled you to create bodies, but essentially a file was considered to be one single part. That is not the case in Onshape. Within Onshape, a part studio makes parts. Notice it makes parts and not bodies. Every time you create a new body, I'm using my air quotes, but because I'm ugly, my camera's not on, each of those bodies is considered a part. It has its own parts number, color, appearance, and so on. So one of the immediate things to take away from this is that you probably don't want to create more parts or bodies in a part studio than you actually need, especially because the parametric history is a single serial record. That's going to be important later when we look at other workflows such as Derived. Updates are immediate. A change to a part in a part studio immediately affects all the other parts that are built around it or off it. What's really nice about building parts in a single part studio is that the geometry cannot be screwed up by changes to spatial relationships between the parts. What do I mean by that? Parts defined within a part studio to have relationships between them are immune to changes in their spatial relationships or positions within an assembly. I am a former SOLIDWORKS user. It's a great product. I was actually worked for the company for a very long time, but I was perennially having to help others through the challenges of designing parts in the context of an assembly such that when the part in the assembly, the features would still regenerate predictably. And in fact, it was such a challenge that many companies resorted to edicts requiring that external references be frozen or locked or perhaps even broken, or in some cases, banned from even being created in the first place. The reason being that the company and the engineers did not like the fact that they would open up a part and it would be bad, or they would open up an assembly and it would be entirely blown up. You know what I'm talking about. Use of multi-part part studios with an Onshape gets around these problems. Another benefit of building parts in a single part studio is that a single feature can be used to affect multiple parts. We're going to look at this in just a moment, but it's nice to be able to know that, for instance, a fillet radius needs to only be changed in one place. I can't tell you how many times I've forgotten to change a fillet radius in one of any number of files that I've been trying to manage. Within Onshape, if the fillet radius, for instance, is the same on both parts or end parts, it becomes very easy to use or edit the same feature to control both of them. Another thing that's not specifically related to multi-part part studios, but that I really love, is just how robust the Booleans are. Yes, we're going to do a little bit of high school Boolean lesson, but just in summary, it's perfectly valid with a Onshape if A intersect B is a null set for the result of a Boolean operation to be null, or that the result of a Boolean operation be anything other than one body. In almost every CAD system that you're used to, if the result of any Boolean operation is anything other than one discrete body, you're going to get an error message or a failure. We can take advantage of that within Onshape to come up with some very powerful regeneration capabilities. And then we will look at a quick custom feature, and custom features, as you know, work within part studios. How much should you put into a single part studio? Any two parts or more parts that are related to one another. Could you build the entire assembly, your entire product design in a single part studio? Of course you could, but you might not want to do that. The reason being that a change to a feature that only affects, in your mind, one part might actually cause a regeneration of other parts. Not that the geometry will change, but that you would be unnecessarily regenerating features. For that reason, and I'll restate this, how many parts should you build in a single part studio? Just those parts that are related one to another. Let's take a look at some examples. I am going to open up this casting, and it was an initial part that was designed by someone starting with an imported sketch. I like to show an example of this because it's not an uncommon workflow to start with an imported sketch, perhaps from another system or a DXF or a DWG file, and then rebuild it in Onshape or another professional grade CAD system. Quick reminder, and I'm going to do this throughout this presentation, is to show you some quick tips and tricks. One that I like is the final button. In case you're wondering, the final button appears on any dialog or feature that isn't the last feature in a rebuild list or the last feature before the rollback bar. This happens to be the first feature in the feature list, so there is a final button, and of course you can figure it out by now. It essentially rebuilds all the features below it. So we started with this sketch, and there are a number of features that someone else perhaps has gone through, and I'm simply going to continue building the mating part. They are related, so I'm going to take advantage of that. I am a big believer in keyboard shortcuts. There are keyboard shortcuts for many of the icons shown here. The keyboard shortcuts can be accessed from the help pull down. Just say keyboard shortcuts. You can see them all listed here. If you want to pop them out so that you can drag it onto another monitor or print them, there's a nice pop-out button. Works just like in Gmail. And it'd be easy to assume that those might be customizable at some point in the future, Mr. Corcoran. So I'm a big believer in keyboard shortcuts. If you're a fan of the SOLIDWORKS S key shortcut menu, that has also been incorporated into Onshape and is entirely customizable. Again, simple productivity tools that cut down on mouse miles. My preference is to go directly to the keyboard shortcut. I'm going to select this face and start a sketch, and I'm going to borrow one aspect of this profile because I want to go ahead and revolve it. I'm going to say that I would like to then revolve this profile, and the revolve axis is any conical or cylindrical edges you already know, and I'm going to say that this is a new part. So far, you'll notice that my part count went from 1 to 2, and as a good tip, I'm going to go ahead and start naming these. You can go ahead and change the name, the color, and in fact, in a production environment, you're probably going to want to go ahead and assign some part numbers and a description so that we can leverage that later in the drawings and the bill of materials. Continuing, I'm actually going to hide that bottom part for now. As you know, the I is a good one. There's also a keyboard shortcut, which is Y, which is very nice for drilling into part studios and assemblies. And I'm going to continue to work on this. I'm going to take this profile, and I'm going to reuse this circle, and I'm going to use my constraints to pick up this. And in doing so, I'm creating relationships between these parts. I'm going to use Shift-E to extrude, again saying new. It's going to be 20 millimeters, which is the same thickness as the other side. A little bit of advanced geometry creation for you. I actually really like the use of replace face to go ahead and make sure that these parts touch, just to show you how that works, part of the direct editing suite of tools. I say that the face I'd like to replace is this. I'm going to use my tab key to advance through the selection list and say I want it to be replaced by this face. Notice that the geometry was extended all the way through. That's actually what this flip alignment does. And even though I perhaps couldn't explain exactly the logic, it's interesting to note that between these two options, flip alignment and flip offset distance, that there are actually 4 combinations, and it's very quick and easy to cycle through them. Here's another productivity tip. I'm going to use this repeatedly. Shift-Enter accepts the current operation and starts a new one, because I'm going to do exactly the same thing on the other side. I pick this face, I hit the tab key to cycle through the faces. I overshot it, so I'm just going to come back and say replace this with this, and now we can go ahead and do our Boolean. Another quick tip here is the fact that there are 2 types of selection. I'm going to window select. I could just as easily go through and do this from the feature manager, but left to right is wholly within. Right to left helps if I actually capture one of these. Right to left is in or crossing, so it doesn't matter even if the parts aren't wholly within. What is interesting to note is that the first item in this list is the one whose name and color will be preserved. So for that reason, you might want to go ahead and say, I want to Boolean union this, this, and this. Did I get them all? There we go. And if I've made a small mistake, I'm going to come back to the revolve and say, hey, I didn't need it to go all the way around. I actually only wanted it to go in one direction, 180 degrees. And I can see the final button just to make sure that it's what I wanted. Yes, it is. Good. So what we've done within a single part studio is create a relationship between these 2 parts, leveraging the geometry that already existed. I gave the example earlier of the fillet as an example of a single feature that you might want to use to affect multiple parts. So I'm going to do exactly that. I'm going to say I want the fillet to be applied to the bottom of this pocket, and this face, and this face. So what I've done is I have a single feature that has applied the fillets to both parts. If I edit the feature, it's of course going to update both those parts. And this is entirely parametric, meaning I can come back to the sketch here at the top. If I say edit the sketch and say final, because final is my friend, you notice that I can come here and I can change any of these values. I'll say that this is no longer 40 millimeters, it's now 50 millimeters. And even though that sketch only defines the top part, of course, the bottom part was built from that and updates. The other thing that I said was a benefit to building parts in a multi-part part studio is that those relationships were unaffected by spatial relationships within an assembly. Here I'm going to hide this bottom part. I'm going to put a make connector here on the origin, and the owner part is going to be the top part. The reason I need an owner part is because I could have just put it here, so that's fine. It would automatically have been the owner part. Because if I have multiple parts and I bring them into an assembly, Onshape needs to know which make connectors to bring with it. Cool. All right, in the assembly, I'm going to go ahead and, it's already here, just pull this off, and I could make this anywhere I want, but it's what's interesting, and I'll show you how to attach it to the origin. So if I said this part, move that to here, I can go ahead and say anti-align with Z, which orients the part with the Z-axis, and then I can then say right mouse button, move to origin. Cool. Next thing I like to tell people to do is to fix that first part. Awesome. When I insert the second part, the bottom, you'll notice that the geometry is correct regardless of where in space I put it and independent of the orientation of the part. So if this was a traditional in-context feature, I'm using my air quotes again, the geometry would be totally screwed up because the geometry would have referenced edges that are now in a different orientation, and the body that was already there is now in a different location. So multi-part part studios give you an incredible degree of robustness to your designs by being able to create geometry that is independent of the spatial relationships in an assembly. Pretty cool stuff. I'm just going to pause for a second. No, we good on questions? Let's take a look at another example of this. Here is a bracket. Here's a bracket. A temptation when building components in a multi-part part studio is to perhaps create more instances than you need. I'm going to use this as an example of a couple of things, one of which is that even though I'm going to need 4 instances of this stepper motor in this gearbox or servo box, I'm not going to design them all in the Part Studio. I only need 1 instance. Here I have created 1 instance of the stepper motor. It's only in the assembly that I go ahead and create multiple instances. And in fact, to make life a little easier and show you some more productivity tips and tricks, I'm going to hide the frame and create a mate connector on this part. And in fact, because I have created a flat, I get to show you something that sometimes bites me, at least. Maybe if I show you, you'll watch out for it. I'm going to use the Shift key. You learned this in training. The Shift key to freeze the make connection points. And as I zoom in, you'll notice that the center of this circle and the center of mass are 2 different locations. This is because there's a flat on the part, and the center of mass does not lie along the axis of the motor. I'm making sure that I select the one that lies on the axis. And just to make doubly sure, I'm going to look at this from the end, and yes, the make connector sits nicely on here. Why am I doing this? Because I'm a nice person, and some other people in my organization might also want to reuse this motor. I'm essentially creating, I'm going to use some SOLIDWORKS parlance here, a mate reference. This is the ability to specify an attachment point before inserting into the assembly to make the creation of the assembly that much easier. I'm going to create my assembly. I'm going to insert the servo frame. I'm actually going to, just as I did before, reinforce how you would actually position a part on the origin by saying, take this part, anti-align this with Z, that just means point down instead of up, and then move this to the origin, and then fix this. This would be like what I did was like an in-place mate or a mate for position only, and now the part's nicely nailed on the origin, and my drawing is going to look correct for front, top, right, and so on. Now I'm going to insert that stepper motor. I'm going to take advantage of the fact that the stepper motor already has a mate connector on it. I'm going to use snap mode, I for insert. I'm going to pick the servo motor, and notice that it's snapping to the geometry as I move my cursor around. Now, this gearbox housing actually came from a system where cylindrical faces are periodic. That means there are two halves to each of the faces. This is most commonly found in CATIA models, and I thought it'd be fun to show to you because it really is a bit of a pain and how we might want to deal with that. So I'm going to say insert the servo motor. I'm actually going to hover over the cylindrical face because that generates 3 mate connectors. And now I have some keyboard controls to orient this. A for align, Q for clock. So I'm going to clock this until the flat is on the top. And if there were multiple mate connectors, perhaps for a bolt with and without a washer stack, I think it's the Alt key. Someone correct me in the chat if it's wrong, to cycle between the various positions. And I'm just going to keep doing this. I'm going to pick up this one, and I'm going to come to the cylindrical face, and here we go. I'm going to hit A for align, and I'm going to clock it. There we go. A for align, bingo. And I'm just creating mates on the fly. If you look at the feature manager on the left-hand side, now some of you will say, well, Philip, there's a populate. There's an auto-populate. You're absolutely right. There is an auto-populate capability. I didn't clock that one. I'll come back and fix it later. But it's interesting that the parts would all appear in different orientations because the auto-populator is only looking at one face at a time and then rotates the frame of reference when working on the other side. So it's actually faster for me to do it this way and this and back to the top. Good. So there you saw how I would insert 4 instances as opposed to developing them all in the Part Studio. Now, some of you will have noticed that I have a bunch of mate connectors. Mine are bigger than yours, sorry, but there is a nice keyboard shortcut to hide them. It's the K key, K for mate connector, of course. So that's how we would prevent us from having to build unnecessary geometry in the Part Studio, and the build materials will be correct because if we look here at the build list, you'll see we have servo motor instance 1, servo motor instance 2, servo motor instance 3, and so on. Now, what about this one that was in the wrong orientation? Just a quick bit of cool stuff with assembly management. If I click on the part, if I hover over the mates, you'll see that when I get to the one that's wrong, I get a nice little symbol. I can go ahead and edit this and just rotate the flat to the correct orientation. Good stuff. Looks like I got a couple of them wrong, so let's fix that. Let's edit this and clock it. Awesome. So there's another advantage of Part Studios, the advantage being that you don't have to generate more geometry than is needed. You're only creating 1 instance of each. We okay, Noah? Let's look at another example. Here's an example where the advanced Booleans within Onshape allows us to do some very cool things in a multi-part Part Studio. Here I have a Part Studio that contains a number of snappy together type building blocks. And I've reached the point where I've mirrored and patterned these a number of times, but really there aren't that many parts. There aren't 24 of these parts. There are actually only 2 or 4 parts. So let's go ahead and say I'd like to Boolean them these together. And it's interesting because there are actually going to be 6 or 12 discrete sets of. Actually, let me just undo something for a second. This is Philip not resetting his demos. Okay, so that's better. There actually, I actually only have 6 discrete parts here, even though there are 24 bodies. So here I'm going to use the Onshape Boolean to Boolean these together, and we're going to go from 24 parts to 6 parts. And that was because the Onshape Booleans don't care what the total number of output bodies are. They can be from 0 to n. They're all perfectly valid results. So much so that they are very resilient. For instance, if I come to this linear pattern and edit it and show final, you can see that if we change the pattern spacing, watch what happens to the final part count. If I change it from 50 to 55 millimeters and hit enter, because there's now a space between two of the starting parts, when the Boolean happens, you'll see that we go from 24 to 12. Does that work?
24 to 6 to 12.
Yes. So it doesn't matter what the total output is. I might have got that backwards, but I think you understand the point that the Booleans will regenerate regardless of the total output number of parts and regardless of the fact that the total number of output parts may change. So let's go back to the slides and just have a quick recap. So Part Studio makes parts. Each body is a part. Don't build more than you need, right? We didn't build 4 of the stepper motors. Yep. Updates are immediate, so a change in a Part Studio automatically updates the other parts and any assemblies used in this document. Parts cannot be screwed up by changes to spatial relationships, meaning when I put the parts in the assembly, their relative orientations does not matter, and there's no need to lock or freeze external relationships because of the nature of the way the parts update. As you learned in training, when you reference a part from outside of the document, you're referencing a named version, and you get to control when that named version updates. One feature can affect multiple parts. So remember the fillet, we added a fillet that filleted both parts, and in a moment we'll come back and I'll show you some custom features. So that's multi-part Part Studio. And as a general rule of thumb, this is your first go-to. Can I build 2 parts in the same Part Studio to capture the relationship between them? It's the easiest and most robust. And this entire presentation is going through an order of desirability or decreasing desirability, how you might want to affect those relationships. The next topic is in context. In context is probably familiar to some of you because you came from other CAD systems that supported it, but Onshape is a little bit different, so I'm just going to define some of those capabilities. In context allows you to create or modify geometry or parts using geometry in an assembly. In context allows you to create or modify parts using geometry from other part studios, and we're going to follow that workflow through. One of the many nice things about in context is that the contexts, and I'm going to define that in a moment, update only when you want them to. This is really nice because change doesn't propagate in an unchecked fashion. There's no being caught by surprise when you open up your assembly that features are in the wrong place or the parts have failed to rebuild or all your mates have blown up. You get to decide when the update happens. And the in-context capability also allows geometric references to multiple positions and multiple external references. And this is one of the key differentiators of the way Onshape does in context versus other CAD systems. Just to make the point and drive it home, no one else can screw up your parts because you decide when the contexts update. And I'm going to show you workflow. There was a thread on the forums that I was involved in that was asking the question, how can I Boolean together parts that are in an assembly? So I wanted to show that workflow to you. I also wanted to show you that you didn't have to do everything in your master assembly. I wanted to show you a workflow that made use of dummy assemblies to build the parts that you want. And just because it's familiar to some of you, I'm going to work my way through a master layout and master part workflow. So let's get started. I am going to do a general overview of in context by looking at an assembly that we've been working on. Here I have an assembly of the x-axis of a printer carriage. Very easy to figure out how this works. Let me just pull up the assembly, and you can see that we have a number of parts that have been mated together such that when I move this carriage, we go, everything spins. If it's not smooth on your screen, that's just the frame refresh. So there are a couple of things that I probably want to do here. The first thing I'm going to do is to build the belt, and this is probably the more traditional in-context operation that you're used to. I want to build part in the context of the assembly. I'm doing this to give you familiarity. To create a brand new part in the context of a Part Studio, to create a brand new part in the context of the assembly, select Create Part Studio in Context. I need a starting point, and to nominate a starting point, I either need to specify the origin of the assembly as the frame of reference, or a mate connector that I have attached. Well, here it makes more sense to go ahead and use the origin. Think of this as the in-place mate, but I promise you it is much more robust than a traditional in-place mate. What happens at this point is that a new Part Studio is created. It's going to contain no geometry, no new geometry, because I haven't built anything yet. What it does do is that it ghosts or brings in all the geometry that was in the assembly in which I created the in-context Part Studio. Now, I don't like seeing my planes everywhere, so I'm going to just hide them. Look at my feature manager. There is nothing listed here. And in fact, I'm going to introduce a new concept now. The name of the concept is a context. Currently, there is no context. A context is something that is created at the Part Studio level and says that there is a relationship between this Part Studio and the assembly. There is no context yet because I haven't created a relationship. I'm going to create one by defining a plane that exists between the midpoint of the end of this pulley. Now, just by clicking on it, new assembly context, context 1 was created. And you see this little title here, assembly context. This just means that there is now a relationship between this Part Studio, not a part, this Part Studio and the assembly that it came from. So I'm going to pick this face, which is going to define a plane. And you can see that this plane that we've created has this arrow that says, hey, this plane is a feature that is an in-context or contains an in-context reference. Later, you're going to see that all parts created by this Part Studio have external references. The reason I'm telling you this now is to reinforce the notion that a context relates to a Part Studio. It doesn't relate to a specific part. And now that I have this plane, I'm in a position to build my belt. I promised you that I was going to use a custom feature. If you want to know how to use a custom feature, just go to the onshape.com/ it's called feature script, but it really should be called custom features. And there's a whole bunch of information and libraries of very cool custom features, but I wanted you to see how easy it was to use. There is a belt custom feature that requires a midplane. That's the one we just created. There's a belt thickness, 0.675 millimeters, and it's 6 millimeters tall. And the pulley faces are this and this. So you can see how we've stretched the belt across these two pulleys. The location and size of the pulleys are determined by the size of the parts in the assembly and their spatial relationships. So, quick summary, we started a new Part Studio, we ghosted in, like editing it in context, the assembly, and we created references to existing geometry which created a context. A context relates to a Part Studio, not to any individual part. And there's a quick tip, I strongly recommend that you name the context, because later you're going to see how we can have multiple contexts. I'm going to insert this part back into the assembly, part 1. I could have created as many additional parts as I wanted here in this Part Studio, but for now I'm just going to say, hey, this comes back to the assembly. Notice that there's a new part. I'm going to kick myself now and later for not naming it belt, so I'm just going to say belt. And I also missed out on an opportunity to remind you that you can get from any assembly back to the Part Studio containing the part by saying right mouse button, switch to, which takes you back to the Part Studio that contains the geometry, which is really nice, especially if you have a large number of Part Studios. Cool. Now, everyone wants to know what happens if the location of these changes. So I'm going to take this drive assembly, I am going to edit this mate, and I'm going to change the offset to -29 millimeters. And you'll notice that the drive assembly updated. The belt is now the wrong length. This is a very important and powerful capability of Onshape's context. No one else can screw up your parts. You get to decide when the context updates. I can go to the part or here in the geometry and say update the context, or I can do it here in the feature manager, right mouse button, update context. I don't have to edit it. I just say, hey, think of this as a rebuild, except it's more powerful because I'm updating only this context. And it goes through without leaving the assembly. You can see how the length of the belt updated. We're in good standing. All right. That was a very simple workflow that many of you were already familiar with, other than the new concepts of a context and the new concept of updating specific contexts. I'm going to hide the belt because I want to show you something that's really rather unique. I have this carriage and it stops at each end because there are limits to the mates. In the real world, it might stop because it's actuated this limit or micro switch. Now I need to build a little ramp here to allow the micro switch to actuate, so I'm going to go ahead and move this to the end. I could have used the named position views to capture this location. In fact, that's a good recommendation if there aren't hard limits based on limits put on mates. And I'm going to say right mouse button on this part and say edit in context. This is going to take me to the part studio, and remember everything that I've said before. You're going to see the part and you're going to see the assembly ghosted around it. The assembly is in the position that it currently is, or was in when I created the context, and you can see that this carriage is at the left-hand end. I'm now going to start a sketch on this face, and as soon as I start referencing this geometry, you'll notice that a context is created. So when I hit use, 3, 2, 1, go, you'll see that, hey, a new assembly context was created. And that's because Noah sounds like he's about to say something.
We have a question about, can you do nested contexts, and what happens with circular references?
So I don't know what the definition of a nested context would be. My apologies. I do know that it's impossible to create a circular reference. Onshape simply will not let you do that.
Can we reference a new context? Can we make a new context referencing the part that was created as a context with nested? I think the answer is yes.
So for those of you that didn't hear Noah, the question about nested context was restated as, can you create an in-context feature to a part that was created in context? I thoroughly believe that to be the case, although I personally haven't tested it. Remove through all. So what I have now is I've created that notch, and I've created a context, and I need to call it rename left-hand end. That was probably a bit overkill, and now I'm going to return to the assembly. What is really, really nice about this is that now that in-context feature stays valid even when I move the carriage. Now, just to supply some, what happens if, because I'm sure 50 of the X hundred of you are typing furiously, watch. So this part has two context to it, or it has a context to it for now. So if I say update the context, because I've moved it, what's going to happen? Everyone thinks it through. You're correct, the notch will disappear because the notch cannot be created in this position. If I move this back and say update the context, the notch will reappear. So this is why the named positions are useful. Now I happen to be able to take advantage of limit mates. So now let's go to the other end. So I'm going to drag it to the other end, and you'll notice that there's a limit or micro switch here as well, and I'm probably going to want to do something similar. Usually at this point someone types, well, can you just mirror it? Well, I could in this particular case, but what if the offset from the end was different? Here we're going to create a brand new context. I'm not going to edit an existing context. I'm going to say edit in context. Remember the last time we did this, the assembly was ghosted in shown at the left-hand limits of travel. Well, now it's ghosted in showing at the right-hand limits of travel. And now I'm going to create a brand new context. I'm going to select this face, start a sketch. I'm going to borrow this geometry. And as soon as I say use, you'll see that a new context has been created. So now I'm going to come up here and say this and this, a tangent. I'm not sure if it did. Yes, it did. And I'm going to pull this over here. A slight difference between the way Onshape does use edges in other CAD systems is I actually get 3 constraints, one on the entity and one at each end. So in order to be able to drag the end, I need to delete the constraint at the end, and I'm going to do the same 15 degrees here. And There we go. Cool. And I'm going to remove this material through all. Fantastic. Notice that I have two contexts now. I'm going to rename these right hand, I can't spell, right hand end. Okay. So now I have two contexts. I have left hand end, where the carriage is shown the left hand, and right hand where it's shown the right. Now all of you are thinking, oh, open, closed, stowed, deployed. Good, that's exactly the way you're supposed to be thinking. Because now, when I go back to the assembly, let's imagine that the right hand switch mount was moved. So I'll edit this, and I'll say that this has been moved over another couple of millimeters. And you'll see that, oh, maybe it didn't. I'm not sure which one it was. Oh, thank you, it is the other one. Minus 48, minus 48. There we go. So, what do I want to do? Do I want to update the left context? Nope. I only want to update the right context because now there are two contexts. There's a left-hand end and a right-hand end. Because I moved the right-hand microswitch, I only want to update the right-hand context. And it updates as expected. So, recap then. Onshape in context supports the traditional create new part in the context of the assembly. Onshape also supports the ability to create multiple contexts, that is the ability to have components in multiple positions and only update the context that you want to update. Let's look at another example. I'm going to take a look at this motor mount that I'm, weldment perhaps, that I'm building. It is a gearbox mount for twin NEMA 23s, and I've already built the mounting, the attachment plate and the mounting plate. I only have one attachment plate because in the assembly I'm going to put the other instance, and somehow I've got to figure out how to put the geometry on here of the motor. So I'm going to create an assembly. I'm going to insert the entire contents of my part studio. And I'm just going to fix this first part and then mate using M for mate. And I want the center of this to the center of that. Actually, and I get to hit Control C, Control V, and do the same thing again. I want to mate that to here. Good. Now, this is my assembly. It's going to be a weldment of these three parts. My assembly does not contain the NEMA motor. So even though I could insert the NEMA motor and then do the in-context creation of the mounting holes, that is not what I want because my bill of materials would be correct. This is where I said, don't be afraid of creating dummy assemblies. I'm going to create an assembly, and in that assembly, I'm going to put the motor mount. I'm just going to fix it. I'm also going to insert from other documents. I'm going to look for my NEMA 23 version 2 assembly. And I'm just going to put it here. And I'm going to mate it. I'm going to mate that to the center of here. I'm going to flip it over. And now I'm going to edit this part in context, which means jump back to my part studio, and I'm going to do the Boolean subtract. My target is the motor plate. My tools are, what's the easiest way to do this? Probably just this plate and the 4 studs that make the holes. And I'm done. Now if I jump, I'm going to rename the context. I'm going to say NEMA 23 mounting holes. I don't have to stay in the context. I can say none, and the assembly will disappear, because now I can check to see that I've got the right geometry, and then when I jump back to the assembly, you can see that the parts have the correct geometry. So the lesson here was, don't be afraid of dummy assemblies. I don't need to screw up my bill of materials by putting the NEMA motor in here. I can go ahead and insert it here and do an editing context. I'm going to say dummy mounting assembly. So the question was just asked, what happens if you delete the dummy assembly? The mounting holes will disappear. Or actually, the external references might be broken. They might not disappear, but I recommend keeping it around. What if you wanted to change from a NEMA 23 to a NEMA 17, something like that? Cool. One more, there is a thread on the forums, which is a great place, that talked about Booleaning things together that are in an assembly. I realize I'm 46 minutes in. This will probably go the full hour, even though I said it wouldn't. Isn't that always the case? So I have a floating bed frame that was brought in from multiple parts and assembled. But what if I was putting this in a larger model and think of this as a weldment? I need to join all of these parts together, and they are built from multiple disparate documents and multiple disparate part studios. How on earth would I do that? So here in the full assembly, I'm going to say I would like to create a brand new in-context part studio referencing the origin. Here's my part studio, and you'll see there's no geometry because I haven't created any, and everything was ghosted in from the assembly for this context. Now the context hasn't been created yet, so let's go ahead and do that. How am I going to Boolean these together? I can't pick the parts, so clearly there's something else going on. The trick is to do a transform and to do a copy in place. And it wants to know, what do you want to copy in place? Boom. Just Windows select this, because this will transform every part in the assembly into a part in the part studio. In this case, there are 18 parts, and of course, a context was created. And I'm going to rename the context. I'm going to say the context is, you know, weldment join. And I'm going to drop out of the context so that nothing else is visible, just to make my life a little easier. I've got all these parts. I'm just going to say Boolean union, all of these. And now I have a single bed weldment. So now I have a single part that I can use in another assembly, or in fact, as you all know, weldments get part numbers. So I'm going to say properties, and this is going to be a, you know, bed weldment, and it has a part number BBB123, and this is R1. Good. So that was a methodology using editing context to create a Boolean union of a bunch of parts in the assembly. So that was in context. Let's go back to here. In context can be used to create or modify parts using geometry in an assembly, create or modify parts using geometry from other part studios. That was the NEMA motor mount example. You only update the context that you want when you want it. Onshape in context allows geometric references to multiple positions, and the name position views is going to help. No one else can screw up your parts. And I showed you the workflow that allows you to create new parts from the Boolean of disparate parts in an assembly. And don't be afraid of dummy assemblies. Oh, I left off one. Let's just quickly do a master layout. You'll get the idea very quickly. So if I open this document in a new tab, you can see that, or you will in a moment, that I have a part studio containing a master layout sketch. And I have a piece of 80/20, which is some just metric 2025. I'm a big fan of 80/20. In fact, once again, Philip's going to reset his demo. Yes, you can delete contexts. Cool. All right, so here is my master layout. I have the ability to put this into my assembly, insert, a sketch. The sketch is the master layout sketch. That was an enhancement made a number of releases ago, the ability to put sketches into an assembly. I am going to fix this because I don't want the sketch floating around. And I am going to insert in my piece of 8020. I'll just go ahead and put it here. And I'm going to mate it because this is the classic frame generator. Now, the workflow is, I'm just going to say it, not ideal yet, but we're certainly getting closer every release, and it's exciting to know that I can start building 8020 frames. What you will eventually need is one part studio for each of the different lengths of 8020. To do that, I would simply duplicate the part studio for as many different lengths as you needed. This is 8020. I'm going to mate the bottom of this 8020 directly to the sketch. For those of you that didn't know, you can actually mate directly to a sketch. And I am now going to edit this part in the context of the assembly. So I say edit in context. And what happens is when I jump to the part studio, I get the master layout. And in fact, if I was smart, and I just realized this is even better, I would have put planes at the ends of these sketch points. We will have extrude up to vertex soon. Do we have that yet, Noah? Is it really? So I'll just use the word soon for now. So in the meantime, I'm going to say, I'm going to do a line point and here. So now I have this plane, and now I can say context has already been created because I referenced the master layout. I'm going to say replace face, replace the end of the 8020 with this plane, and now I've created the master layout relationship because I can now use this master layout sketch in any number of other assemblies, in any number of other part studios, and everything updates. So if I come to the master layout sketch and change the length to 200 millimeters, when I come back to the assembly, you can see it's too long until I say update the context. And it's likely you'll have three contexts, one for length, one for width, and one for height. Very powerful. Question?
What happens to the context when multiple branches from different designers are brought back together and certain features are kept but others are not?
Okay, so we've got some very smart people in the audience. The question was, how do external references and context relate to branches and versions? I'm just going to say I don't know right now. Why not create a couple of examples and post them in the forum so we can see? But you have motivated me to go back to my desk and try it. So this is new functionality, and that's probably a really good question we need to, or I at least, need to understand, or at least ask the people that built the stuff. So one last, were there more questions? So I've got 7 minutes left. Let's talk about Derive. Derive allows you to parametrically reference a part in another part studio. Derive allows you to modify the geometry to create a new state. I'm going to use cast and machine for my example. It has its uses and it has its places. I have to tell you, and it's in bold block letters, Derive is very expensive. It's an expensive feature, meaning it takes a lot of CPU cycles and a lot of time to regenerate. I'm not going to say it's your last resort because it most definitely has a place. I'm going to show you why it is expensive and why the high cost is incurred. Please do not use this for standard parts. For standard parts, you're going to insert into an assembly or in context. Again, do not use this. Do not use Derive for standard parts. In almost all cases, the use of Derive, as formerly taught by me and others in class, can be replaced by in context. This is a case of new functionality being available in Onshape, and you should now take advantage of it. It's highly likely that the remaining cases will be obviated by the arrival of configurations. Of course, we're going to have configurations. Every professional grade 3D CAD system does. They're coming. Don't be afraid of dummy assemblies as a means to get around using Derive. And I'm just going to say try not to use. That said, I'm now going to show you an example where it is appropriate. So here I have a casting. The casting was imported, and I need drawings of the as cast and the as machined. Of course, you would typically use configurations to do this, but here I have the as cast. Here I have the drawing of the as cast, complete with section view, and I am going to now develop the machined. And what I started with was derived, which brought in the derived part as is. If you're a SOLIDWORKS user, this is akin to insert part from another document. And then I added the features that represent the machining operations, whether it's a facing on the mating face, or the machining of a fillet, as I'm about to do, or perhaps the application of machined holes. Here I've got a bunch of counter board holes and some through-wall mounting holes. Typical machining operations on a casting. I might also have created a drawing of the casting, and in fact, because I've made some changes, I of course have the update button. That's what the yellow button means here. And if we take a look at these views, you can see that the geometry reflects that. The 2D drawing reflects the geometry of the casting, and I've got my intelligent machined features that are automatically annotated, or rather, when I add the annotation, they are correctly and automatically annotated, and I've got my locations of the holes. How does Derived work? If I come back to the as cast, I could go ahead and say I wanted a fillet that is 12 millimeters across that entire face. Now, of course, the as cast drawing can be updated anytime I need it to. I do not have to update it. I'm just going to simply switch to the as machined Part Studio. Now, why is it taking so long? All I was doing was putting a number of holes on. This is the cost and penalty of Derived. I'm not saying don't use it, I'm just saying understand the implications. Derived is like GoSub. When we build this Part Studio, it says, oh, you're derived from something. It's going to jump back to the as cast and rebuild all the features in the as cast. What if there are 10 parts in that parent Part Studio created by 100 features, 10 each? Only 10 of those features actually needed to be regenerated to rebuild my as cast, but I went through a regeneration of 100. Derived is very powerful. It is useful, but please understand that it comes as a cost, and in most cases could be replaced by in context. And now, of course, when I come to my drawing, you can my machine drawing. Here we go. When I go ahead and update it, you'll see that the fillet propagates all the way through from the as cast to the as machined to the as machined drawing. Right, I actually did manage to get through all this in an hour. We're going to hit a summary slide in a moment once the drawing comes back, and hopefully you now have a little bit of a better idea of the overview of the various ways of relating parts together. So here I have lessons learned. Onshape supports multiple workflows: multi-part Part Studio, in context, and Derived. Multi-part Part Studios offer some unique advantages in terms of robustness and the ability to relate parts one to another. In context makes possible a whole new level of robust design by allowing you to control when the in-context features update and which in-context features update. And you just learned Derived has its place, the as cast, as machined example, but is expensive. And know, as always, that we are continually improving Onshape and that more workflows are coming. 159, Noah, nailed it. How are we doing on questions? Awesome. This recording will be available to all the people that registered for the webinar. I very much appreciate the very large number of people that have joined us here today. And please, please, please watch for the What's New announcements in Onshape, because we are continually adding new workflows and capabilities.
Can you say that the recording will automatically be sent via email sometime today or tomorrow?
A link to the recording of this webinar will be automatically emailed to you sometime today or tomorrow. We're going to stick around for a couple more minutes if there are any more questions, but at this point you are free to leave, and I've enjoyed, as has Noah, presenting to you this afternoon. Thank you very much.